Hello again, this is MA 108, section 5.1, homework help, video number 2. In this video we're going to be looking at number 27, number 35, and number 75. Okay, so for number 27, we are asked to find the exact value of arc cosine of -1/2 without the use of a calculator. Once again, I have no objection to when you're finished, you're checking your work by actually typing arc cosine of -1/2 into your calculator, but you need to show all these steps to make sure that you've demonstrated your ability to find these values without a calculator. So what I do, as always, is I take my arc cosine and I set it equal to something. I like setting it equal to theta. So I have theta is equal to the arc cosine of -1/2. Then I take the cosine of both sides. And when I take the cosine of both sides, I get cosine of theta on the left. And then I have arc cosine of -1/2 inside cosine, and this simplifies to -1/2. So in other words, I have cosine of theta equals to -1/2. On the unit circle, there are two places where cosine is equal to -1/2. Those are the two places. But remember, for cosine of theta, I restrict the domain to be from 0 to pi. So this value is not the case for pi over 3. This one down here is outside of the domain. So the correct value has to be theta equal to 2 pi over 3. Theta equal to 2 pi over 3. Okay, number 35. Here I have the situation where I'm being asked to evaluate arc sine of -1 over root 2 inside the cosine function. So once again, what I do is I take the arc cosine or arc sine or arc tangent part. In this case, it's the arc sine part. I take the arc sine part and I set that equal to theta. So in other words, I have cosine of arc sine of -√1 over 2 or cosine of theta. This would be equal to cosine of theta because this I'm saying is equal to theta. Theta is equal to arc sine of -1 over root 2. Then I apply the sine function to both sides. I'm applying the sine function to both sides because I want to find the inverse to undo arcsine. So on the left-hand side, I have sine of theta. On the right-hand side, I have arcsine of -1 over root 2 inside sine, and all of that simplifies to -1 root 2. So in other words, I have sine of theta is equal to -1 over root 2. So I'm then trying to figure out arcsine is limited from -pi over 2 to pi over 2. And so I must be talking about -pi over 4 to get me to this -1 over root 2, which is the same as -root 2 over 2. So I restrict sine from -pi over 2 to pi over 2. And I'm asking where is sine of theta on that domain equal to -root 2 over 2. And that's equal to that at -pi over 4. So that's theta. But remember, what I'm trying to find is cosine of theta. Cosine of theta, because I'm saying this is theta. So cosine of theta. This is theta, so I need to find cosine of theta, which is cosine of -pi over 4, which is root 2 over 2. So cosine of arcsine of -1 over root 2 is equal to root 2 over 2. Okay, number 75. We are given arc cosine of x inside the sine function. We're told that x is between -1 and 1. And we're asked to rewrite this sine of arc cosine of x without any cosines or arc cosine functions. So the first thing I did was take the arc part, so the arc cosine of x, and set that equal to theta. That's always my first step. Whatever the arc part is, I set that equal to theta. Then I took cosine to both sides, so I get cosine of theta is equal to arc cosine of x inside cosine, and this right-hand side simplifies to x. So I get cosine of theta is equal to x. In other words, cosine of theta is equal to x divided by 1. That's the same as cosine of theta equal to x. I drew a standard right triangle, and cosine is adjacent divided by hypotenuse, adjacent divided by hypotenuse. And now I need to figure out what this other side is, b. So I use Pythagoras' theorem, x squared plus b squared equals 1. Solve for b, and I get that b is equal to the root of 1 minus x squared. So then sine of theta is equal to sine of theta, because remember, I made theta equal to arc cosine of x. Theta equal to arc cosine of x. So sine of theta is equal to sine of theta, and sine of theta is the opposite over the hypotenuse. Well, the opposite is b, which is this root 1 minus x squared over the hypotenuse, which is 1. And so that simplifies to the root of 1 minus x squared. So therefore, my answer, arc cosine of x inside the sine of x function, simplifies to 1 minus x squared underneath the square root. And notice all my